we ask ourselves, how many different license plates could we make? Just follow along. I'll get there, people. It's not like you've had every single day of notes I've done that, then today I'm doing it different. Just play along with me, Miller. So we've got how many letters to choose from? 5. How many blanks are we going to fill, or how many spots? Okay, how'd you do this one? Ms. Smith, how'd you do this one? Yes. Not yet. We're getting there. It's okay. It's called a leading question. Thank you, Malik, for ruining my surprise. Okay, how did you approach this one? How many? How? Or I have no idea how to do this. Alec? 20. How'd you get 25? 600. How'd you get 625, he says. Yep. Okay, so there are 5 different letters for here, 5 here, 5 here, 5 here. What operation did you do with those numbers, Alec? Yep. Okay, so 5, 5, 5, 5. So you can have a license plate A. Okay, so there'd be 625. The units on that would be different ways. No, but this is really how they find the number of license plates to make sure they have enough. Is 625 enough for the state of Colorado? Probably not. Probably not even enough for DCC. What about if letters are not allowed to be repeated? How would this change? Letters are not allowed to be repeated. Talk to the person sitting next to you. If letters are not allowed to be repeated, so you can't have A. It has to be a different letter in each blank. How would that change the number of ways? No, you have to have 5 different letters, or 4 different letters. 4 different letters. You cannot repeat.
So there will be only 5 options or 4 options or 3 options?
All right, volunteers, how does this change? Besides Ms. Smith, she's already talked. Besides Malik, you already talked. Somebody else. Melissa.
Okay, so you have 5, 4, 3, and 2. So when you multiply those together, you get 120.
Why are there so many less?
Because you can only pick from 1 or 5, and then whichever one you pick, you have to take it out for the next one. And so you can only pick out a 4, and the next one you can only pick out a 3, and then the next one 2.
Okay. Absolutely. Does the order matter that the letters appear in? Is A, B, C, D, E the same as D, C, B, A? Are those the same license plate? No. So does the order matter?
No.
Yeah, the order is important. Yeah, if you change the order, it's a different license plate. Today, 7374. Probably the first time you've ever actually taken notes that you had this title. Today we are going to learn counting rules. The goal for today, number 1, given a situation, you have to be able to determine the number of ways it can occur. Determine the number of ways that it can occur, which means we have to count. And number 2, answer the 2 key questions, which I'm going to tell you in just a second. Answer the 2 key questions for counting. Yes, sir. Can occur. And number 2, answer the 2 key questions for counting. You may say, what are those 2 key questions? Here we go, the 2 key questions for counting. And away we go. Here they are. Number 1, can the items be repeated, or can results be repeated? Like, can you have A? Like A for the first, A for the second, A for the third. And the second question is, does the order matter? Can items be repeated? In other words, if you choose somebody, can you choose them again? And think of it like for contests. If you're going to choose a person out of here to win a graphing calculator and a person to win a vacation to Hawaii, if you won the vacation to Hawaii, does your name go back in the hat for the drawing for the calculator, or you're already good enough? Well, the difference is it changes the number of ways things can occur, because as Alyssa mentioned, it changes the number of outcomes that are available for the next step or for the next drawing. Okay, as Alec mentioned right off of the start, the first thing we use is the multiplication rule for counting. If you want to count the number of ways to involve a multi-step event, it is the number of ways to do the first event times the number of ways to do the second event times the number of ways to do the third, all the way up to the last one. And we consider the last one to be the letter R. Now, could R be really big? Yeah, we could have like 50 things we need to choose from. Could R be really small? Yeah, it could be as small as 1. Does it make sense to choose 0 things? No, there's only one way to choose 0 things, and that's to choose nothing. There's only one way to do it. Last, all the way up to the last term. Yep. R is the number of, what's that? Yep. R is the number of spots or the number of things we're going to choose. So like in the license plate one, we had 4 blanks you're going to choose, so R would be 4. And N is the number, N is the number of outcomes or the number of options. So in our license plate one, we had 5 letters to choose from. That would have been our N. You're going to choose 4 out. That would have been our R. Your book uses different letters for this at the start. I'm not going to follow that because then we reteach you different letters. I'm just going to use the same ones the whole time. Okay, so then we note the example Alec came up with. If replacement is allowed, then the number of different ways is probably the easiest formula we're going to get all year. It's N to the R power. Like notice Alec had, he had 5 options. We were going to fill 4 blanks. We allowed it to be repeated every time. So it was 5 times 5 times 5 times 5, which is 5 to the 4th power. That's if we allow them to be replaced, or if we allow them to be repeated. Another way of saying that, if we allow them to be repeated. It's just the number of ways to the R power. Easy. Number of different ways is equal to N to the R power. Dylan.
Are we going to go through the funky bean thing?
Oh, yeah.
Is that
not today, though. Today we learned the exclamation point. Today we learn like an exclamation point. Exclamation point. Yeah, it's back from geometry. It's a very excited in. Okay, let's take a peek then. Let's do an example real quick. Example 1. You have 30 friends. Oh, people, you have way more than 30 Facebook friends. 30 Twitter followers. Yeah. Okay, you have 30 friends. You choose 1 to go to Hawaii with you, and 1 to get a calculator. I know, which one is the real first prize winner is the question, but your question is, if you allow the same person to win both, so in other words, if you allow a replacement, how many different ways could you give these away? Could you give these away? Probably take you longer to copy than figure. 30 seconds, ready, set, math. Allowing replacement, yep. So the same person could win both. Who has not talked yet today? Miss Claire, how many ways do you think we could do that? Yep, 30 to the second power. Bam, which is what? 900. What's the units on virtually every question in this chapter? Different ways, right? Okay, now a strategy for you when you get home tonight. If you have trouble visualizing this and you're a visual learner, draw blanks. You're going to pick two things. And you'll notice I did that for you on the first one because most people can do this visually if they can't just know it off the top of their head. Draw the number of blanks and fill in how many people can win the first prize, 30. How many people can win the second prize, 30. And then the multiplication rule says if you have two events, the number of ways to do both is to multiply the number of ways to do the first times the number of ways to do the second. And bam, Claire's shortcut much quicker. Don't pack. Whoa. I'm going till 30 after. Don't pack up yet. We still have one more thing to cover. What's that?
Let's put at 25.
Yeah.
He gets out of 30.
No, it's out of 25.
Gets out of 30. We started it.
It's out of 25,
Christ?
I guarantee you.
I will check it out at 30.
30.
That's at 11.
Yeah, class started at 11. It's 90 minutes. You're thinking Thursday. Third period gets out Thursday to 25. Do not worry, Colonel Bouchel. I made sure she got those extra 5 minutes of math. No child left behind. Okay, but now let's get a little harder. What if we do no replacement? I wonder if you ever tried to leave lacrosse/football/wrestling practice 5 minutes early to get to another one. What if there was no replacement? Now we run into a little different area. With no replacement, we first have to learn a letter, which is this exclamation point. This exclamation point stands for the words factorial. There is a button on your calculator. If you actually go second catalog, it's the first button that comes up is the exclamation point. What does factorial mean? Factorial. Like 5 factorial means you take 5 times every number less than it till you get to 1 and multiply them together. So 5 factorial is 5 times 4 times 3 times 2 times 1. And you'll notice I asked you that with the license plate problem because I said, well, what if we can't use the same letter twice? There's no replacement. We can't replace A again. What's that? Let's take out the calculator and I'll show you. With no replacement, go to second, and then the button that does everything. Factorial. What are you from? You're not from Minnesota enough. There's an I in there? Yeah, there's Bryce, there's an I in there. Go to catalog. Actually, I take it back. It's not the first one. Go to math. No, it's not catalog. Go to math. Go to math. Math.
Just normal.
Math. Hit math. Shh. Just math. Notice how when 30 people talk, nobody hears anybody else but themselves. Okay, go to math and go over to the PRB menu. That is probability, and you'll notice there's lots of things we're going to use under that. There is an exclamation point on that. So real quick, on your own, find 10 exclamation point or 10 factorial. And it is factorial, you're correct.
Well, that's a big number.
That's a big number. So what does that tell you? If you had 10 things you had to choose and there's no replacement, so you had 10 friends and you had 10 prizes, everybody wins one, how many different ways could you hand out those 10 prizes? That many ways. But just so your parents know that you're getting your money's worth, let's take a look at one quick. No, we won't take one quick. Okay, we covered everything we need to for that selection without. Yep. Here we go. I suppose. Page 443 tonight. You get to do 1 through 2. Haha, that's not it. 5, 6, 9. No. We got more. 11. Nope, that's not all I got one. Oh, 14. That's a fun one. And thank you for your help. And what else? 17 through 19. Let's go to band. Have a good day. Bell didn't ring. You are out of here.